Right, so in this part two, we're going to use the double angle identities to find more complex um, arrangements of angles. So question number two here says, assume that the angle alpha is in the fourth quadrant and that sine of alpha is minus 12 over 13. Assume also that the angle beta is in the third quadrant and that the cosine of beta is minus 3 over 5. Compute the exact value of cosine of alpha minus beta, cosine of alpha plus beta, sine of alpha minus beta, and sine of alpha plus beta. So the key thing here to do is to actually find what is the other part with respect to a specific angle. So for example, we have the sine of alpha. We need to find out the cosine of alpha. We have the cosine of beta. We need to find the sine of beta. Of course, this is super easy because we can just go ahead and use the identity cosine square of alpha plus sine square of alpha is equals 1. The key thing here is going to be using the information about the quadrant. But we'll go back to that in a second. So first here we have that sine of alpha is minus 12 over 13. So we can just write cosine of square of alpha plus minus 12 over 13 square equals 1. So cosine square of alpha is just going to be 1 minus, and whatever this is, which is, this is 144 over 169. That's 12 square over 13 square. And so now we are going to simplify this. So cosine square of alpha is going to be 169 minus 169. That's how I can write 1. And this is 144 minus 169. When I do this subtraction, I'm going to get 25 over 169. And so now, because I want to get cosine of alpha, not cosine square, then I'm going to do cosine of alpha is equals plus or minus the square root of 25 over 169. And that is plus or minus 5 over 13. Now you might be wondering, well, but this is plus or minus, so how do I figure out if it's plus or minus? Because it can only be 1. So that's where the information about the quadrant comes into play. So if you remember, we usually associate x with the cosine and y with the sine. Okay? Because this is telling me in the information of the quadrants, then we're going to find out what that is. So here in the first quadrant, you remember x is bigger than 0, y is bigger than 0. Here in the second quadrant, y is bigger than 0, but x is less than 0. Here on the third quadrant, we have that y is less than 0 and x is less than 0. And finally, in the fourth quadrant, we have that x is bigger than 0, but y is less than 0. So we have that y is less than 0, that's fine. Sine of alpha minus 12 over 13, that checks out. And so now we need x, which is usually related with cosine, to be positive. So this means that the cosine of alpha gotta be positive. And it's 5 over 13. So with this, we have half of the information that we need. Now that the other half will be finding out exactly the same thing, but with beta. And so that's precisely what we're going to do now. So we can go ahead and do it from here. But another way that you can go about doing this is using the right triangle. And so let me just do that as well. So notice that we can think of a right triangle And this is the second way that you can approach this problem. So the cosine is adjacent over hypotenuse. So this is telling me, hey, the hypotenuse is 5 and the adjacent is -3. And then I don't know what this part is. I don't know what the opposite is. And of course, then this is gonna come to the same thing. So hypotenuse is square, 5 square, is gonna be equals to the opposite square plus -3 square. And so this is gonna be 25 is opposite square plus 9. And I'm gonna move this 9 to the other side. And so this is going to be 16. And so the opposite square is going to be 16. And so now if the opposite square is 16, that means that the opposite should be plus or minus 4 when I take the square root. That's going to give me enough information for the sine, because then the sine of beta is going to be opposite, which is plus or minus 4, over the hypotenuse, which is 5. Okay? But then we have the same information. Now this angle beta is in the third quadrant. So the third quadrant, we should have that sine should be negative. So we have the y's lessons here. So sine of beta should be negative. And so this means that is going to be really -4 over 5. And now we got all the values that we need. We have this, we have this. And you gotta be extremely careful for the next part, because now you have all the values, but if you make a mistake, then you can still get the question wrong. This is cosine of alpha. Here you gotta implement the formula. This is cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. And so cosine of alpha here, I just found it, 5 over 13. Cosine of beta is here, -3 over 5. Sine of alpha, I have it here, -12 over 13. And sine of beta, I found it here, -4 over 5. Notice that you need to write everything first in the formula and then replace by the values. Do not plug. Do not plug. That's the most common mistake. Do not plug these values. These values are not to be plugged. Now, same thing for cosine of alpha plus beta. So it is the same thing. The only thing that is going to change is the sign, because now this is going to be cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And so here is going to be 5 over 13 times -3 over 5 minus -12 over 13 times -4 over 5. And of course, you gotta simplify this, but this is just arithmetic, so I'm gonna skip that part. Now for the sine, remember, you gotta be careful using the formula. This is sine of alpha, cosine of beta. We have a minus here, so we use them same minus, and then sine of beta, cosine of alpha. And then now we match up with the values. Sine of alpha is -12 over 13. Cosine of beta is -3 over 5. And then sine of beta -4 over 5. And cosine of alpha 5 over 13. Okay. Sine of alpha plus beta. Then this is going to be sine of alpha, cosine of beta, plus sine of beta, cosine of alpha. So this is just the same thing here, but instead it's going to have this values. And it's going to have a plus here. Now the last question is asking in which quadrant is the angle alpha plus beta? Well, that's like finding out what is the x and the y for alpha plus beta and if they're positive or negative. So over here, you can see that you're going to get 15 over something, whatever 13 by 5 is. This 50, 80. This is minus 15 over 80. And this one is actually 4 by 12, which is going to be 48. And is negative, very negative. Sorry, positive, very positive, minus by minus. So 48 minus 15 over 80. So this is going to be a positive amount. The cosine, cosine of alpha minus beta. And the cosine of alpha plus beta, this is going to be a positive amount. This is going to be 48. And this is going to be minus 15. So it's kind of the same kind of thing. But here we have a very negative thing because the 48 is negative thanks to this number. So here we know that this is going to be negative, and we need to find out the sine of alpha. Here we have 36 positive, 36 over 80, and this is 20. So minus 36, minus 36, minus 20. So this seems like it's going to be a negative as well. Let me double check. Yeah, negative, and this is positive. So 36, no, never mind. Making a mistake here. Okay, so minus and minus plus, 36, and then 36 minus 20. So this is positive. So we have a positive y and we have a negative x. So negative x is here, but with positive y, we have in this second quadrant. And that's it. Number 3 is also the same thing. It's very similar to what we just did. Now here we have the quadrants in different positions though. So let's do it again in the same way. We're going to assume that angle alpha is in the first quadrant and cosine of alpha is 8 over 17. So for the first one, I'm just going to go, and this time I'm just going to make it with a triangle. And so I'm going to call alpha A to be here. And so the adjacent is 8 and the hypotenuse is 17. And I'm going to call this opposite, I'm just going to call it y to make it simpler. And so I'm going to have 17 squared is equals to y squared plus a squared. Okay. And now, of course, I need to find out how much that is. So I'm going to go by 17 times 17, which is 289, equals y squared plus 64. And so 289 minus 64 is equals y squared. And that's going to be equals to 225. And then we're going to take a square root of that. So square root of 225. And that's going to give me 15. So I'm going to get y is plus or minus 15. This will give me enough information to find the sine. So sine of A is opposite, which is plus or minus 15, over hypotenuse, which is 17. But now, but this is in the first quadrant. And in the first quadrant, remember, both x and y are positive, so sine of alpha got to be positive. And so sine of alpha becomes 15 over 17. And so that gives me the information on A. So now I can do the same thing for B. And just remember that if you prefer to do this with the trigonometrical identity, you can also do so. This is just one way, right, of doing things, but and it's gonna lead to the same place overall. So let me just do it here for this. So I'm gonna have that. Let me put it over here. Sine square of B is 1 minus cosine square of B, right? Well, I'm trying to find cosine, so let's do it backwards. So I have cosine square of B is 1 minus sine square of B from the identities that we have. And so this is 1 minus 5 over 13. And so this is 1 minus square, of course. And this is 1 over 25 minus 169. And so I actually have information in this because I got the same numbers before. So 169 minus 100 over 169 minus 25, 169. This is going to be 144 over 169. And so that's going to be the cosine square. So this means that the cosine of B is just going to be the square root of this, which is plus or minus 12 over 13. And so again, let's take a look at the quadrant. B is in the second quadrant, so the cosine should be negative. So but beta belongs in quadrant 2, so that means that cosine of B should be negative, minus 12 over 13. And so I'm pretty much done at this point. I have all the information that I need. I just need to plug back in. So this is going to be cosine of A cosine of B minus sine of A sine of B. And so cosine of A I have here is A over 17. Cosine of B is minus 12 over 13. And then minus sine of A, 15 over 17. And sine of B, 15 over 13. And so on and so forth. We continue plug in the values. Wait a minute, this is minus, so here we should have a plus instead. And then this one that is plus is actually going to get the minus. You got to be really careful with these formulas because otherwise we can make the mistake that I was about to make in there. So here's same values. Okay. And same with the sine. Sine is just the easiest because you don't have to modify the sign. Sine of alpha minus beta, sine of alpha cosine of beta minus sine of beta cosine of alpha. And so sine of alpha, 15 over 17, cosine of beta, minus 12 over 13. Sine of beta, 5 over 13, times cosine of alpha, A over 17. And same thing for this one, but it's going to have this sign flip around. So we're going to have the plus in here without no issues. So 15 over 17 minus 12 over 13 plus, and then 5 over 13 and 8 over 17. And of course here you gotta simplify what this is, but this is a good point where at least you have a lot of things done with this type of exercise. Okay, so with this we conclude part 2. Part 3 will take the trigonometric identities more in detail.